Hello students, I am Madhukar Sopin, Assistant Professor in Chemistry, Vijayanagar College Hospital, belongs to B.Sc.II University Ballari. Now I will take the B.Sc. second sem class, part 2 under physical chemistry. The chapter is liquid state. Under this liquid state we are studying now intermolecular forces. When a substance is in the liquid state, its molecules or atoms are held together by mutual attraction. Without these forces, the molecules or atoms would expand to fill all the space available and becoming a gas. If the intermolecular forces are less, then they will become the gas. These forces are not strong as compared to forces in solids, and these forces are not so weak as in gases and are between solids and gases. We can measure the strength of the intermolecular forces in liquid state through the boiling point, shortly you can call it as BP. The more tightly the particles are held together, the more heat energy will be needed to separate them into a gas. Conversely, if intermolecular forces are weak, the boiling point will be low. If the intermolecular forces is more, the boiling point is high. If the intermolecular forces are less, then the boiling point will be low. There are four main types of intermolecular forces from strongest to weakest. The first one ion-dipole forces, second one dipole-dipole forces, third one dipole-induced dipole forces, lastly fourth one induced dipole, or another name is dispersion, another name is according to the scientist name London forces, and all these four are nothing but van der Waals forces. So dipoles means what now? We have to study. Dipoles means an electrically asymmetric, opposite to the symmetric, asymmetric molecule. If a molecule is not electrically symmetrical, a positive charge will accumulate on one side and a negative charge will be on the other side. Molecules with dipoles are said to be polar in nature. So these are polar. Example, HCl molecule. In this, because of the high electronegativity of chlorine atom, it attracts the electron pair towards itself. So it acquires the charge delta minus, small negative charge. And because of the loss of electron, this hydrogen acquires a small positive charge, they are represented as delta plus. So H delta plus, Cl delta minus. Water molecule H plus OH minus, or you can write in the form of this. So this is delta plus one end, another one end is delta minus. Non-polar molecules do not have dipoles. Example, benzene molecule C6H6. This is not able to form the two electrical poles, so it is an example for the non-polar molecule. Similarly, another liquid pentane C5H12 is also an example for the non-polar molecule. The first type we will study now, ion-dipole forces or ion-dipole interactions. Here, a charged ion is attracted to the dipole of a polar molecule. These are the most powerful types of attractions. The example is dissolution of salt like sodium chloride in water. Here, negative charged Cl- ions will be attracted to the positive dipole near the hydrogens, while the positively charged Na+ ions will be attracted to the negative dipole of the oxygen atom. That is NaCl gives rise to Na+ plus Cl-. Cl- is in this case is attracted by the positive end of this dipole. Na+ ion is attracted by the negative end of the dipole. This is called migration of ions. These attractions are powerful enough to split apart the NaCl crystal when it enters water. This means that the salt NaCl dissolves. If the crystal structure is too strong to be broken by attractions between a solvent and the ionic solid, then the solid will not dissolve. The attractions between the positive and negative in the case of salt is very much, in that case it is very difficult to dissolve that. So that type of salt will not dissolve. This is first. Second one is dipole-dipole forces or dipole-dipole interactions. Here dipole-dipole forces act between the molecules possessing permanent dipole. Dipole will be permanent. Ends of dipole possess partial positive charge designated by delta plus and partial negative charge designated by delta minus. These partial charges are always less than the unit charge of electron. compared to the value is 1.6 into 10 to the power of minus 20 coulombs is the electron charge. It is always less than this value. The polar molecules interact with the neighboring molecules. I will draw the diagram afterwards. Figure A shows electron cloud distribution in the dipole of the HCl molecule. Figure B shows dipole-dipole interactions between two HCl molecules. So in the second case, dipole-dipole forces, we have two cases, A and B. This figure A indicates the distribution of electron cloud in polar HCl molecule. So HCl molecule, I told that it is polar. Hydrogen carries the small partial charge delta plus, chlorine carries the small negative charge delta minus. That means more charge, electron charge density towards the chlorine atom because it is highly electronegative compared to hydrogen. Then if two such hydrogen chloride molecules will come very close to each other, in that case, so dipole-dipole interactions will take place between the two HCl molecules in this way. This is chlorine delta minus of this molecule, hydrogen delta plus of this another molecule. So opposite charges are there. This is the dipole, this is the dipole. So such type of interaction you can call it as dipole-dipole interactions. And this is existing between the molecules like two HCl molecules. The attractive forces decreases with the decrease of distance between the dipoles. If the distance is more, then the intermolecular forces decreases. Here the interaction energy is inversely proportional to distance between polar molecules. So this is one type. Another is under the same subtype of dipole-dipole interactions. It is hydrogen bonding. First we have to know that the definition of this hydrogen bond. What is this hydrogen bond? Hydrogen bond can be defined as the attractive force which binds hydrogen atom of one molecule with the electronegative atom, either fluorine or oxygen or nitrogen of another molecule. This is called the hydrogen bond. Since each of electronegative atoms like fluorine or oxygen or nitrogen wants electrons more than hydrogen, a dipole will result. These dipoles result in strong attractions between the molecules. Example, intermolecular attractions in hydrogen fluoride molecule. So this HF dotted lines indicates the hydrogen bond. So this hydrogen is bonded with the electronegative atom of fluorine. This is the hydrogen bond. And the bond between the H and F, stick line, this is nothing but covalent bond. You know that covalent bond is formed between the sharing of the electrons between hydrogen and the fluorine. This is hydrogen dotted line and thick line is covalent bond. Other examples of this hydrogen bond, they will exist in the case of water, ammonia, methanol molecules. All of these molecules have high boiling points due to the unusual strength of hydrogen bonding. Due to the formation of hydrogen bond between those molecules, the boiling point is very high. I think you followed this one. Thank you all.